Hi everyone, welcome to the Microsoft Online Tech Forum. My name is Aaron and I'm a Cloud Solution Architect from Microsoft Hong Kong, specializing in the data and AI solution area. This session is about moving your database to Azure, which I will show you some options that you have if you want to migrate your databases from on-premise environment to the Azure cloud. I'll firstly give you a high-level overview of the Azure Data Platform. Then you'll be able to learn more about the process, tools, and services available for the database migrations. Finally, I will show you a demo scenario where a company is moving its SQL and NoSQL databases to Azure with the help of the Azure Database Migration Service.
Firstly, you may have the question, why should I move my databases to the cloud? So let us take a look at the typical reasons why people may want to perform a migration. For example, your data center contracts are going to expire, and now it is time to maybe rethink your strategy going forward. Should I continue to renew and manage my own data centers, or should I move to somewhere else? Maybe you have acquired a new company, or maybe you have been acquired, and you may face the challenge to have hybrid data architecture that you need to integrate them together. Of course, we support a number of different popular database systems on Azure, and we'll be looking at that very soon. Another important factor would be having a very successful and popular application or product, and you need to quickly respond and scale the infrastructure such that you can fulfill all the incoming requests at the certain peak hours, but also not to run them every day 24/7, because in that way you can optimize your costs and you only need to pay for what you consume. Some other factors could be related to software and hardware refresh cycles, security threats, compliance concerns, such as how do you make sure that you can fulfill the GDPR requirements if they are European customers, for example. So finally, application innovation is also important because we are now in 2020. We may want to incorporate some of the new features and have a modernized approach in terms of how we manage our data estates. And in case you don't know, Windows Server and SQL Server 2008 have already reached the end of support, so maybe it's also the time to upgrade to something better. So on Azure, we do offer a comprehensive suite of products and services, and specifically, what you see on the screen is just some few examples that I want to show you on the Azure Data Platform. So if we start off from the left to the right, we have Azure Data Factory for most of the batch data ingestion scenarios and integration scenarios, and you can leverage the Event Hubs, IoT Hub, or Kafka for real-time data ingestions. For the data storage part, we have different database services like Azure SQL Database and Cosmos DB, and also object storage solutions such as Azure Blob Storage and Data Lake Storage, which is optimized for big data analytics. In terms of data management, you can use our Azure Cognitive Search and Data Catalog capabilities. For data processing, data analytics, and data warehousing scenarios, Azure Synapse Analytics is the next generation analytics platform evolved from our previous Azure SQL Data Warehouse service, which includes both SQL and Spark engines with a single unified experience. Of course, if you prefer to use a fully managed Hadoop and Spark platform on Azure, HD Insight and Databricks would be suitable for you. In case of real-time and stream processing requirements, we also have Azure Stream Analytics that integrates well with Event Hubs and IoT Hub. So finally, in terms of the data modeling and visualizations, machine learning, and AI, Azure Analysis Service, Power BI, Azure ML Service, and Cognitive Services are available for you as well. So the advantage of having an end-to-end data platform built on top of Azure is that they all share a common secured infrastructure, and you can benefit from the tight integration in terms of the identity, security, monitoring, and etc. So today, our focus is on database migrations. So let us take a look at the different managed database offerings on Azure. So in terms of relational databases, we offer Azure SQL Database, which is a managed SQL Server. For those who prefer using open source database engines, we do have our fully managed offerings for MySQL, PostgreSQL, and MariaDB. If you're looking for an open source compatible in-memory data store, Azure Redis Cache would be your choice. Last but not least, for non-relational NoSQL type of database workloads. Azure Cosmos DB is a multi-model database that natively supports different data models, no matter you're looking for a key value, column family, documents, and graphs. So typically, we see that database migrations follow a process with careful planning. So before any kind of actual work, it is necessary to perform some kind of migration assessment where we will involve all the relevant stakeholders to discuss potential technical blockers, to calculate the TCO and justify the cost, to discover and evaluate all the related apps, such that because this may also involve app modernization efforts as well. So it is also important to have a clear cloud migration strategy where we are looking at whether we are looking at rehost, or some may refer it as lift and shift, where we simply push the whole application and database to the cloud without any changes. So some may also choose to refactor to take advantage of cloud services with minimal code changes. So some may want to re-architect and modernize the application such that it will become a resilient, highly scalable, and independently deployable architecture. So finally, some would simply choose to rebuild the whole application using cloud-native technologies. So after we have defined the migration strategy and performed all the necessary assessments, the actual migration is usually handled by the migration tool itself to migrate the data and schema. So some tools may also help you to perform the data sync during the migration, such that we can achieve a minimal downtime. Finally, database migration does not really stop right after the migration. So you may want to further test and make any necessary changes to ensure that everything is running smooth and working properly. With managed database services, you can even further optimize and adjust your database resources based on the workload patterns so that you can achieve the most out of the cloud. So we have talked about the database migration process. So now let us take a look at what are the tools and services available from Microsoft for your database migration journey. For the assessment phase, Azure Migrate is the centralized hub for managing and tracking all of your Azure migrations, which also include VMs, applications, and databases. Data Migration Assistant, DMA, is a tool for accessing a SQL Server to migrate to the Azure SQL Database service. So it will check for any potential compatibility issues. So if you're using, let's say, non-MS SQL engines, so you will be looking at the SSMA. So the SQL Server Migration Assistant is another tool for you to scan and check for the potential migration issues when you want to move to Azure SQL. So some of the supported migration sources in SSMA includes DB2, MySQL, and Oracle. So for the actual data and schema migrations, then you will use the Azure Database Migration Service, which is the end-to-end fully managed solution for migrating from multiple database sources to Azure Database Platform. So the Azure Database Migration Service itself is designed to support different kinds of migration scenarios for both offline, one-time migration, and also online continuous migrations. So with offline migrations, application downtime would begin at the time when you start the migration. So you will stop everything and wait for the migration to finish and to connect back to the new instance. But however, if you want to limit the downtime to the minimal only until the point where a final cutover is necessary, so you may also choose to perform an online and continuous migration. So both kind of scenario is also supported with the Azure Database Migration Service, and it is recommended to test an offline migration scenario first to determine whether the downtime is acceptable, and if not, then you can go for an online migration instead. So as you can see in this table, as of today, we support a different combination of database targets on the left and the sources on the right. So I would highly encourage you all to try this database migration service for free and to look into our documentations for more details. So for the upcoming demo scenario, we'll be using the database migration service to help us to migrate a SQL Server and a MongoDB from on-premises to the cloud. So first of all, let me introduce this imaginary company called Tailwind Traders. So it is a retail company that sells furniture, kitchen appliances, and home accessories, and also other DIY stuff. So they have recently acquired another company called Northwind, which is a very traditional company that runs and operates their own data center. So however, Tailwind Traders is exactly the opposite. They are very modernized and innovative and most importantly, and they are a global company. So that's why their strategy is to go global and to move all the existing on-premise databases to the cloud. So here is the existing architecture that we have. Let's assume that the application layer had already been moved to Azure, which is an ASP.NET web application with React.js on the front end. So for those who would like to learn more and to learn how to migrate the application layer as well, so I would recommend you to review the previous session before this session, which is about the migrating web applications to Azure. So back to the migration scenario, we see that this web application is currently connecting to two VMs sitting on premise. Let's assume it's sitting on premise. So one of them is running a SQL Server 2012 for the product catalog information, and the other one is running MongoDB for the shopping cart feature. So let us start with moving the SQL Server to Azure SQL Database, and then we will handle the MongoDB next. So when we are talking about the SQL Server modernizations, I would say that Azure SQL Database is undoubtedly the best managed database service for you. So Azure SQL Database is an evergreen and version-free platform that is always running on the latest stable version of the SQL Server engine. And that is also fully compatible to the backward versions as well. So it means that you do not need to perform any further upgrades from one version to another, and you will see all the newest capabilities of SQL Server being introduced and released first to Azure SQL, then only to the SQL Server itself after a certain period of time. Also, as this is a fully managed database service, we will also provide you with the built-in high availability, backups, and other common maintenance operations. So Microsoft will handle all the patching and upgrade of the underlying SQL engine, OS, and infrastructure. And all these operations are actually transparent to the users, and we guarantee a 99.9949 of SLAs in terms of the database availability. In addition, there is also built-in intelligence and the advanced security features introduced in the Azure SQL Database. So for example, there is a database advisor feature that can continuously assess and analyze the usage history and provide users with customized recommendations based on the workload patterns, which can help to improve your performance. So the automatic tuning feature can also help you to automate the performance tuning of the SQL databases, such as creating index, drop index, or forcing the last good plan. So it will do it by continuously learning with AI and machine learning algorithms across the whole different Azure SQL database patterns. So in terms of security, the threat detection feature provides an additional layer of security, so which will enable you to detect and respond to potential threats by providing some security alerts. For example, you will receive some of the alerts based on some suspicious database activities, like potential SQL injection attacks, and also for some kind of anomalous database logins and access patterns. Last but not least, the vulnerability assessment can help you to scan your database regularly for any misconfigurations, which is based on our Microsoft's best practices and recommendations. So Azure SQL Database also offers different kind of deployment options as well. So we have managed instance, single database, and elastic pool. So some people may be confused about these kind of different options, and they may think, oh, so which option should I choose? So here's a high-level overview and guidance. So single database is a fully managed and isolated database, which is similar to a contained database within the SQL Server. So you may want to use this option if you have a modern cloud application and microservices. So that would be more suitable for cloud native application in that way. So Elastic Pool is a collection or a group of single databases with shared set of resources such as CPU and memory. So with Elastic Pools, you can move different single databases into or out of a pool so that they can share different resources to maximize the use of resource and to save costs. So finally, managed instance is a fully managed instance of the SQL Server, which is similar to what you have on premise, which you can create multiple different databases within the same SQL instance. So this option is therefore designed for seamless migration of on-prem SQL Server to Azure without any kind of application code changes. And it has the best compatibility in terms of the SQL Server features. With Azure SQL Managed Instance, it also provides a native virtual network implementation to address some of the common security concerns, and our existing on-prem SQL Server customers with active software assurance may also bring their own license to use it in the Azure SQL Database platform. So now let us go to our first demo and see how we can easily lift and shift a SQL Server to Azure SQL Managed Instance with minimal changes. So now let us take a look at the demo website first. So here we see that this is the demo website of the Tailwind Traders, where they may have this kind of e-commerce website. So if you take a look at different products that they have, so maybe they sell this kind of products in different categories. And these kind of product informations and product catalogs are actually being stored in the backend SQL Server. Here we have modified the website a little bit so that it will show the backend SQL Server instance and also the MongoDB server. So as you can see, these are currently running on VMs. So you will see their IPs. So let's start by going into this SQL Server VMs. So in this screen, if we open up the SQL Server Management Studio, we can see that this is the SQL Server 2012, and actually there is a Tailwind SQL instance and a database, and there's a lot of different product catalog tables within this database. So the first step we have is to do some kind of assessments so that we know whether this SQL Server is ready to be moved and migrated to the cloud. So first of all, we can make use of this tool to perform an assessment. So let's give it a name, and here we can choose which kind of server type we would like to use. In this case would be the SQL Server, and the target as well. So it can be either SQL database, which is the single database option, or it can also be the managed instance option. So after creating this project, then I will be able to see which kind of assessment and which kind of reports I would like to see. So it can help you to check whether there are any database compatibility issues or if there are any feature parities, such as some of the unsupported or partially supported features if you move to the Azure SQL database. So after that, I will need to input my source SQL Server credentials. So in this case, I'll just copy and paste over some of the values. So in this case, I have this SQL instance. So after that, it will prompt you to choose which databases you would like to do the assessment. And you can simply start the assessment. So after several seconds, or maybe depending on how large is your database, so we'll actually show you the report. So here, first of all, you can see the feature parity. So whether there are any feature discrepancies when you move from on-premise SQL Server to the Azure SQL database. It can also check for the compatibility issues as well. So this will be helpful when you would like to migrate or upgrade from one existing SQL Server versions to another SQL Server versions. But as we mentioned, Azure SQL is actually a versionless or version-free platform, so that it also has this backward compatibility to the previous different versions. So as you can see in here, so it is actually very compatible with this SQL Server 2012, and we are ready to go now because we have already performed all the assessments and make all the necessary changes, if any. So if there are any feature discrepancies or compatibility issues, this tool can also suggest and recommend what are the remediation steps that you have to do or the changes you need in order to be fixed so that it can migrate to the Azure SQL. So you can see here, you can also save the assessment results, export it, or to upload this report to Azure Migrate such that you can have a single hub for all the migration activities. Okay, so let us go back to the Azure. So in Azure, you can create a Azure Database Migration Service resource. So after creating this resource, you can start a new migration project. So where I will just name it as SQL Server Migration. Again, you can choose your source server types. And in the previous table, you will see that we actually support different source database systems. So here in this case, I will choose SQL Server and the SQL Managed Instance. And here you can choose between offline and online migrations. But for simplicity, I'll just use offline for this demo. So after that, it will ask you for all the source and target database informations, and this database migration service will actually do all the work for you. So in this case, I will just input back the name, which I use the SQL Server authentications. Copy and paste my password. And this will actually now check whether this credentials is correct, whether this DMS service can actually connect back to your source SQL Server. And it will ask you for the target server information. So in this case, I have already created my managed instance. So I'll just copy and paste over my username and password as well. So after that, it will also check again whether these credentials are correct, and it will ask you to select which kind of databases you would like to move from your source to the destination. So in this page, it will ask you to select any kind of logins you would like to migrate. So this will only support SQL logins as on Azure SQL platform. We do not have Windows login anymore, but instead we will introduce the Azure Active Directory login so that you can also integrate your on-premise Active Directory with the Azure Active Directory to have this seamless experience when you move to the Azure SQL. So after that, you will need to have this further migration settings, whether you would like to provide the backup files for this service to use, or you will let this database migration service to help you to create all the backup files. So it will also ask you for the network share location, because at the back end, this service will actually help you to take a full backup on the source server, and it will store it in this location. And then it will try to upload this backup file to the Azure storage. So that's why you will also need to provide the credentials for the Azure storage accounts. So finally, of course, you will also need to provide it with a Windows account so that it can impersonate you and to help you to upload the files to Azure storage. So again, I will copy and paste over my username and password. So after all these settings, you are actually good to go, and the database migration service will help you to do all the work. So let's give it a final name, migration activity. So when I click on run migration, this will actually kick off my migration, connect to the source and do the backup, load it on the file share, and then it will upload to Azure Storage. And at the end, it will restore it back on the Azure SQL Managed Instance. So the good thing about Azure SQL Managed Instance is that it also supports native restore and backup commands, so that you can also restore, do a full backup, and load it into the Azure SQL Azure storage yourself, and then you can log in through SSMS to connect to your SQL Managed Instance and to do a manual restore as well. Okay, so as we can see, this will take a little bit of time, but it shouldn't be long because this is actually quite a simple database at the back end. Okay, so here you can see all the information. So maybe you have multiple activities under this migration project. So it is also possible. So here you can also click into the activity details. So here you can see that, so this Tailwind SQL database is actually being restored. So all the copying and uploading should be done. And now it is in the process of restoring the full database backup from the Azure storage back to the Azure SQL Managed Instance. So in the meantime, let us go back and take a look at our SQL Managed Instance. So if you go back to the Azure SQL Managed Instance, you should be able to see this kind of information. And on the left, you can find under the settings, you will have the connection strings. So it depends on which kind of drivers you're using to connect back to this SQL Managed Instance. It already provides you with the connection strings. So you can just simply copy and paste over to use it on your application. So let's go back and check if this migration is being completed. Okay, so now it's completed. So let us try to use the connection string to change this app service, to change this website from connecting to the SQL VM back to the Azure SQL. So here we will go back to the app service configurations, where this application is actually defining the SQL connection string with this file. And now I'm going to copy and paste over the connection string I have just found in the SQL Managed Instance page. So here I will replace the original VM connection string to the SQL Managed Instance. So now if I click OK and save, so this will actually update the web app settings, and it should take around a minute to restart the web application. So in the meantime, let us explore the SQL Managed Instance to see what kind of capabilities that we have. So just now I mentioned that you can actually have the Active Directory integration, so that your users can use Azure Active Directory to log into your Azure SQL as well. So in the pricing tier, you can see that you can actually quickly do an online scaling. So this will be transparent to your users as well if you want to change your settings to adjust dynamically based on the user workloads. Okay, and if you go to this instance failover groups settings, so this page actually help you to easily to create a disaster recovery solution for your Azure SQL database managed instance. So you can define whether you have another instance in another region for DR purposes so that you can add the new group here and to configure that connection. And it will provide you with the read-write listener endpoint and the read-only endpoint such that you can connect to this listener instead of connect back to the original endpoint. So in case there is a failover, this endpoint will always point to the current active instance. So when we look at the security features, so you actually have the option to turn on the advanced data security feature where you can have the vulnerability assessment settings so that this will trigger a periodic scan to check for some of the security configurations within your database and within your managed instance, and you can send these reports to specified accounts or maybe to the admin as well. So for the advanced threat protection settings, this is the feature where we mentioned that the SQL instance, the SQL service will actually give you some alerts in case it detects some of the anomalous activities. For example, when it detects that there is SQL injection, there is some brute force going on, or maybe there's some suspicious logins where maybe probably the normal users are coming from Hong Kong, but suddenly there's a guy trying to log in from the US, for example. Yep. Okay. So in the virtual network, you can also enable the settings where you would like to enable the public endpoint. So by default, this will be disabled because Azure SQL Managed Instance is actually deployed within your virtual network, so it will only have the private IP. But in case you would like to let other, let's say, public applications to connect to it, so you can also enable this public endpoint. So now the application should be restarted. So let us try to see in this case. So here you can see that now these applications actually connecting to the managed instance. So if we browse different product catalogs, these should be all being seamless and transparent to the application. So without any code changes, you can see this is already connecting to the SQL managed instance. So now let us go back to the presentations. So we have successfully moved the SQL Server to Azure. Let's talk a little bit more about NoSQL databases as well. So Azure Cosmos DB is a globally distributed multi-model database service. It is a fundamental service of Azure, and a lot of the Microsoft applications run on Cosmos DB itself as well. With just a simple click of a button, Cosmos DB allows you to elastically and independently scale throughput and storage across any number of Azure regions. You can also enable the multi-master feature so that every region supports both reads and writes. And you can have a guaranteed read and write latencies under 10 milliseconds with a 99.999% 5/9 of SLA. Some people may have the question, what does it mean when we say that Cosmos DB is a multi-model database? So by default, you can use the SQL API to work with your Cosmos database if you do not have any dependencies or preference. But on top of that, Cosmos DB also implements several different APIs, for example, for Cassandra, for MongoDB, Gremlin, and Azure Table Storage. So which means that you can directly use these existing client drivers and tools with this commonly used NoSQL database, and they are compatible to work with Cosmos DB as well. Therefore, your data can be modeled in terms of key values, column families, documents, and graphs in Cosmos DB. So this is a great service for a lift and shift scenario if you want to migrate to a fully managed service without the need to modify your existing applications that is using, let's say, MongoDB. So now let us go to our second demo and see how we can easily lift and shift a MongoDB to Azure Cosmos DB with MongoDB API enabled. So again, this is our demo website, which is a product catalog, which is a e-commerce website selling this kind of different home appliances, kitchen accessories, and DIY tools. So for example, in my shopping cart, this is actually what is depending on the Cosmos DB. So for example, for my, I would also want to buy some of the wooden wardrobes. So I have added something into my shopping cart. So now maybe I would also want to change the number of values that I want to have 2 of these wooden tables. So now we have populated this shopping cart with some kind of data. So let's go back and see our Mongo VM. So I've already SSH'd into the Mongo VM, which is running on Ubuntu. So we can quickly, on this VM instance, we can just quickly do some command and checks. So we see that the MongoDB is actually active and running. So if we try to show DBs, we can see there's the Tailwind database. Let's see what's in it. So we switch to the Tailwind database. We can try to show the collections within it. So there is the carts collection that is storing the shopping cart information. So now let us try to use the Azure Database Migration Service to migrate this to Azure as well. So let us go back to our Database Migration Service, which is here. And I can create a new migration project. For example, this one will be a MongoDB migration. So now my source server would be MongoDB, and the target server would be, of course, Cosmos DB with the MongoDB API. So again, it will ask me for different kind of informations, which is my source server. So probably I'll just use the connection string mode. And after that, I will need to input my target information as well. So the good thing about this is that it already detects that I have some Cosmos DB instance created, and it will populate my connection strings here so that I do not need to do any copy and paste, which is quite handy. After that, it will ask me for the database informations. So whether which database I would like to try to migrate to Azure. So just leave all the settings as the default. Here you can see again, you can change the throughput units and to maybe change the sharding key if you want. And finally, with all this information, this should be good to go, and I can give it a name and to kickstart the migration. So again, this shouldn't take too long as this is just a very small demo database. You can see it's already completed. So let's now go back to our web service and to change it to point it to the new Cosmos DB endpoint instead. So again, we go back to the configurations and we see that this is the original Cosmos DB, the MongoDB connection string. So now we're going to change it into the Cosmos DB1. So I will copy and paste the previous value that I got. And here you can save the settings. So this will take a little bit of time as this app service is going to restart itself. So in the meantime, we can go back to the Cosmos DB and look at some of its features. So if you click into this Cosmos DB account, you can see that this is the card collections that we have already migrated this to the Azure. So here you can make use of this Data Explorer feature where you can also see the underlying information. For example, if I click into this one, you can already see that this is my shopping cart information, some of the products that I have previously chosen. So for the connection strings, you can actually copy from here, which I have already done so. And in this page, you can also easily see that we can easily replicate data to other regions as well. So for example, I would like to have multiple regions for this shopping cart information to be replicated. And I can also enable this multi-master feature where I can enable for multi-region rights as well. So you can see that whether you can choose which region you would like to replicate your data to. So there are also different types of consistency levels within Cosmos DB. So you can see there's a very nice animation to tell you whether you would like a very strong consistency where all the regions will see the same order and same kind of information, or you may actually prefer to have an eventual consistency. Okay, so there's something between as well. So you can have this kind of flexible settings within Cosmos DB. So for firewall, virtual networks, private endpoints, these are some kind of the standard security settings that you may want to use. So in terms of the monitoring, you can take a look at the metrics. So here you can see that if you take a look at the throughput, overview, or availability, you can check that, okay, we actually guarantee a 5 nines of SLA. So you can see this is the SLA. And what is the actual value within the probably, let's say, 24 hours or 7 days, for etc. So the web application should be ready by now. Let us take a look. So if we go back to the original application, it's already now running on the Cosmos DB. So if we go back to our shopping cart, so you can see all the information is still here, as we can see from the Cosmos DB backend as well. So we go back to the Data Explorer and try to add some kind of information. So let's say I would want to add an extra product, which does not exist in the original shopping website. So for example, I can create a new document here and just populate with some sample dummy values. So just as I save it, should be visible on this website as well. So that's the end of my demo. So we have already successfully moved our backend SQL Server VM to Azure SQL and to move our MongoDB VM to the Cosmos DB. Last but not least, open source databases are very important as well. We support MySQL, PostgreSQL, and MariaDB on our managed database services. And they are all based on the open source community additions so that you can easily lift and shift the cloud, lift and shift the existing databases to the cloud and use the existing languages and frameworks of your choice. On top of that, you will of course get the benefit of built-in HA, dynamic scaling, automatic backups, batching, and so on. So if you'd like to learn more about database migrations, you can visit the Azure Database Migration Guide, where we will have documented detailed step-by-step guidance for modernizing different database systems to the Azure cloud.
To conclude, first we look at Azure Database Migration Service, which is a fully managed service that enables seamless migrations from multiple database sources to the Azure Data Platforms, which includes the support for open source databases such as MySQL, PostgreSQL, and MariaDB. For SQL Server workloads, Azure SQL Database is the intelligent, scalable, and fully managed database service that is always based on the latest stable version of the Microsoft SQL Server engine, which also provides the broadest SQL Server compatibility. If you are a fan of NoSQL, Azure Cosmos DB is a globally distributed multi-model database service that enables you to use your favorite APIs such as MongoDB, Cassandra, Tables, or Gremlin, with the advantage of having fast and low latency data access. For those who are interested to learn more, I will highly encourage you all to visit Microsoft Learn and check out our documentations for step-by-step tutorials. If you have any questions, comments, or feedbacks, feel free to let us know, and thank you all for joining this session.